Welcome to Definite Integrals Part 1, Lesson 2, the Fundamental Theorem of Calculus, Part 2. Alright, here we go. We're taking the derivative of the integral of some function of t, dt, from the bounds a to x. This is really cool. Remember that the derivative and differentiation and integration are inverse operations, so they kind of undo each other. So what ends up happening here is the derivative of this integral is just f of x. Okay? So what you're going to do when you see these is you're just going to take that x and you're going to replace it right in there. Now if this were an f of x, you'd have to take the derivative of that and then replace that in there and make a composite function. And I will have a couple examples to show you that. Let's go ahead and move on. Alright, find the derivative of the integral from 3 to x of t squared plus t dt. Okay, since this is just an x, we're just going to replace this in here, and our answer is going to be x squared plus x. Just that simple. No constant, no nothing else, just x squared plus x. Alright, our bounds are backwards. So we're going to take the derivative of the negative integral from 4 to x. Wow, excuse me. Sorry about that. 4 to x of sine t dt. Alright, that would be, just take that puppy in there, replace it, and then negative sine x. Yeah, it really is that easy. Alright, what's going on here? Now we have a function of x as a bound instead of just x. So we got to take the derivative of that and then replace. So the derivative of 5x is 5. So 5e, replace the t with a 5x, 5e to the 5x. Good job. Okay, again, we're going to take the derivative of that function. This happens to be 1. So it would be 1 times the square root of x plus 1 to the third power plus 1. Something's making me really sneezy right now. Alright, so, and then if you really wanted to work that out, it would have been x cubed plus 3x squared plus 3x plus 2 if you multiplied that out and added the 1. But it doesn't simplify after that. Alright, moving along. Okay. Derivative of 2x is 2. Okay. Sine of 2x quantity squared. So 2 sine of 4x squared. Not bad, eh? Let's go ahead and move along. Alright, once again, derivative of that. If f of x equals, this is a little bit different, the integral from 0 to x plus 1 of the cube root of t squared minus 1 dt, find f prime of 4. Well, let's go ahead and first find f prime of x, take the derivative of the left side, take the derivative of the right side, and that would be the square root of, the cubed root of x plus 1 quantity squared minus 1. So f prime of x equals the cube root of x squared plus 2x plus 1 minus 1. So f prime of x equals the cube root of x squared plus 2x. So f prime of negative 4 equals the cube root of negative 4 quantity squared plus 2 times negative 4. So that would be the cube root of 16 minus 8. So f prime of 4 equals that. Need some more room down there, please. So f prime of 4 equals the cube root of 8. F prime of 4 equals 2. Alright, let's move to the big problem of the day. Example number 7. A graph of a function consists of semicircle and 2 line segments as shown. Let g be the function given by g of x equals the integral from 0 to x f of t dt. Okay, this problem was taken from an actual AP test. Alright, let's go ahead and find g of 5. G of 5 equals the integral 0 to 5 f of t dt. So what this is asking is to find the area under the curve from 0 to 5. Alright, so we've got this circle, this triangle, and this quarter circle. And of course the area of the quarter circle is negative. So area equals 1/2 BH for the triangle, and area equals pi squared over 4. Pi r squared over 4 for the quarter circle. So the base and height on that triangle are both 3. So the area of the triangle is 9/2. And the area of the quarter circle has a radius of 2. So area equals 2 squared over 2 squared, wow, pi 2 squared over 4. Area of the circle is pi. So the g of 5 is 9/2 minus pi. Alright, B. Find all values of x on negative 3, 7, that open interval, at which g has a relative maximum. Justify your answer. Okay, the cool thing about this function, the way it's written, g, wow, you can't read that. G of x equals the integral from 0 to x f of t dt. Hey, what's g prime of x from what we learned just a little bit earlier in this video? Oh, it's just f of x. Guess what? This graph right here is the derivative graph for g. So hey, we're just interpreting a derivative graph. So find all values of x on negative 3, 7 at which g has a relative maximum. Where does the derivative graph go from positive to negative? Okay, g has a relative maximum at x equals 3 because g prime of x, also known as f of x, goes from positive to negative at this value. Sweet. We're interpreting graphs again, and I will talk more about this in class. Okay, write an equation for the line tangent to the graph of g at x equals 5. Well, what do we need for a tangent line? We need a slope, and we need a point. We have a point. Here's 5, g of 5. There's our point. And we need a slope. What is the slope of g at x equals 5? Right here. The slope looks like it's going to be, okay, g prime of 5 equals f of 5. f of 5, negative 2. So y minus, we'll put this 9/2 minus pi in parentheses, equals the slope, negative 2, times x minus 5. Boom, done. Don't spend any more time finding a slope. And now, D, find the x-coordinate of each point of inflection of the graph of g, negative 3 to 7. Justify your answer. Okay, where does g prime have a slope sign change? At 0 and at 5. So the answer to D, g has point of inflection at x equals 0, 5 because g prime of x, also known as f of x, has a slope sign change at these values. And here's your last example, example number 8. If f prime of x equals the square root of 1 plus x cubed and f of 1 equals 0.5, then find f of 4. Okay, what you are going to do is you are just going to set up this way. F of 4 equals f of 1 plus, you need a starting point on these, plus the integral from 1 to 4 of the square root of 1 plus x cubed dx. Now there's no way to use biparts or substitution, so you're just going to have to use your calculator and find out what that is on a calculator. So f of 4 equals, well, what's f of 1? 0.5 plus whatever that definite integral is. Hold on, I have to go look. According to my calculations, it is 12.87145. So f of 4 equals 13.37145. All right. This does conclude definite integrals part 1, lesson 2, the second version or the second part of the fundamental theorem of calculus.